very good morning, sir. Today I am here to present about the embedded systems. My topic is embedded systems. At first and foremost, let's forget about the system. I want to ask you one question at first. That what is the meaning of embedded?
Internal, something
Combined. Okay. Something internal. Or you can tell it as a hidden, right? Suppose now we are coming to our topic, embedded system. Suppose there is a chip. Suppose there is a chip, it may be microprocessor, microcontroller, or any type of FPGA chip. Including that chip, you know the architecture of microprocessor, the total computer system is included in that chip, right? Depending on that chip, when something some circuit-oriented system is done, then the total system is called as embedded system. Clear? So let's have a view on the theoretical definition of the embedded system. A specialized computer system that is a part of a larger system or machine. An embedded system is housed on a single microprocessor or microcontroller board with the programs stored in ROM or EPROM, whatever you can use. ROM, if you use the ROM, you cannot change the data, but if you use the EPROM, you can change the data in further. So I am saying that there are several applications of the embedded system, starting from your digital wristwatch, your cell phone, your automatic washing machine, what you use in your home. Everything is the application of the embedded system. Actually, embedded system is a vast technology. Actually, it's a core electronic subset, right? So, I think instead of giving you a big lecture about the embedded system, if I show you a real life example of the embedded system, that so that you can understand that how the embedded system is made and how does it work, right? So, let's see what type of embedded system we are going to make. We are going to make a microcontroller based loading display system. What is loading display system? You can see these types of embedded system in the running bus on road, in the railway stand, in the airport, and sometimes in a reception point in front of gate, in various places. So such type of embedded system when we are going to make, we have to follow some parts, some steps. Like us, you have to know the required software environment, required hardware components, the pin description of the microcontroller of 8052 or 8051, whatever you can use. That's because this pin diagram and instructions that are absolutely the same of 8052 and 8051, and the connection architecture, then the PCB making procedure, and the program code developed. As a reference, I am saying that PCB means the printed circuit code, right? At first we are coming to the software environment. What type of software you are used to make such type of environment? You have to use here the OrCAD capture or OrCAD layout and the Q compiler and AutoCAD and Microsoft Paint. And how this is used, I will say a few moments later. Now we are coming to a hardware environment. What type of hardware environment we actually require? To make the controller board, we have to require the IC74154. It's actually a 4 to 16 line decoder, and 74138. It actually a 3 to 8 line decoder. And UDN2981 means it's a amplifier IC, and Max 232 is the IC for using for the serial computation, and 89C52 it's a 8052 microcontroller, and 82C256 it's a EPROM IC, right? Now, what type of resistors we have to use? 470 you can use instead of that 330 also, and in the controller board when the display board is connecting, at that time you have to use 10K. The capacitor used here 10 microfarad and 27 picofarad, 11.059 megahertz digital oscillator unit, and the connectors, the 32 pin FRC connector and 40 pin FRC connector or 8 pin connector and 4 pin CPU bar connector and RS232 connector with the connect with the Max 232 IC. When I will show you the schematic diagram, it will be more clear to you. And the working equipments like soldering iron, ferroboard, multimeter, breadboard, etc. you can use for your main problem. Now, what type of hardware components we need in the making procedure of display board? High mm LED where we are seeing twin 2904 transistor actually used here, and 100 resistance used here, you can see here, and 32 pin FRC connector also here, and 4 pin power connector is this, right? Now we have to know together about the microcontroller. A 8052 microcontroller have 4 ports, P0, P1, P2 and P3. Here you can see the P0 ports and P1 ports and P2 ports and P3 ports. In the P0 port, it's the open train 8-bit open train bidirectional I/O port. In the P1 port, it's the 8-bit bidirectional I/O port with internal pull-ups, and port 2 acts similar to port 0 when external memory is used, such type of EPROM or ROM, etc. And port 3 is used as a general purpose I/O. Now we have to see the connection diagram, how the display board and the controller board is connected to each other. Here we are seeing the first matrix, second matrix, and up to 10th matrix. It's actually LED board, LED display board. And the display board is selected by the control unit from the 8051 microcontroller or 8052 microcontroller, whatever you use. And the data bus are coming from the decoder to the matrix one. I mean LED board. Right? If you want to take any types of interfacing service, you can do it from memory interfacing, PC interfacing, and keypad interfacing also. Now, every embedded project implementation has divided into 2 parts. One is hardware implementation, that means the PCB making procedure, and another is software implementation, that means the embedded code generation. Now, we are showing here the display board schematic diagram. The display board we are making here 8x6 matrix. You can see here the data line is D0 to D7 and the select line is and the select line 1, 2, 3, 4, 5, 6. Right? So this is the 8x6 segment, and this segment is attached 4 times in your display board. And you know the LED means the late emitting diode, one type of semiconductor diode. So the blue symbol means here the LED, right? And this is the 32 pin FRC connector, and this is the 4 pin power connector. Now this is the layout diagram of the display board, which is coming from the OrCAD layout class. And this is the same similar, we can make the schematic diagram of the controller board. And after coming from the OrCAD layout, the schematic diagram design will be like that. Now you need some attachment of commercial here. Why? Because you have to give the design, the soft copy of your PCB in the PCB making form. From where when you get the PCB, the upper surface of the PCB will look like that. After putting in the IC, capacitor, connector and resistance, the PCB will look like that. And the green board is called here epoxy board or epoxy glass. Now, I have to find out how the program code is developed. The program code is developed with the help of Kill compiler. What is Kill compiler is a big question. Kill compiler is such type of compiler where the C code or C++ code is converted into assembly language programming corresponding to 8052 microcontroller or 8051 microcontroller. So if you can write here the assembly language or C language, but the problem is that in case of assembly language, if you write assembly language, it's quite tedious or tough task to memorize all the instruction set of 8052. So as we are very familiar with the C language, so we can use here C language. The second part is a very important data collected from the graphical design of each character and send it from the microcontroller that display board beside selecting a particular column each at a time. I will show in the next slide how graphical design will be made. And the next point, if we can select each column on display board which is needed and we select them 1 by 22nd by infinite loop, then it seems that all columns are selected at a time. That means if something changes in front of your eyes within 1 by 22nd, you can catch it. So suppose the LED is on or off, it's running within 1 by 20 seconds. It will seem like that the LED is always glowing. Now, I will show the graphical design, how it made. Suppose that is a display board and we want to pass here the message key input, right? The first letter is K. I am showing you the graphical design of K. That there is a select line and there is the data line. Here the red circle means the LED is on and the white circle means the LED is off. Sequentially, we have to make a connection matrix from this. Where S0 and D7, to see here, the S0 and D7 means the LED is on, so we have to put here 1, right? Similarly, we have to put in the question where the LED is off, we have to put the 0. Similarly, when we get all the connection matrix, we have to determine the hex code for each row. When we get the hex code, we have to pass this on your program. Now we are coming how the programming course is made. You have to include there is a header file to h and there for the integer type character for k suppose 6 in this way the hex code will be stored, and when you pass this from your main function, it will show the key diversity in your display board. Now we are coming to the advantage and the disadvantage of the embedded system. The advantage is the lower power, lower cost, sufficiently high on the performance, and the main advantage of this, the customization gets lower area means compact size. And the disadvantage is higher hardware, higher software, needed expert designer, efficient compiler, debuggers, in some cases may result in delay time, etc. And the application. I will say you a interesting thing that AMD, Advanced Micro Devices, has launched recently a funny embedded system like that AMD32-bit AMD robotic dog. You know this? Actually, the functionality is this dog is a night guard of your home. If you go to steal in a particular home, but this type of robotic dog is placed already, you will be caught very soon. There are the different applications of embedded system: the aerospace, automotive, communications, computer vehicles, home industrial instrumentation, medical, office automation, personal, real-time operating system, etc. And the future implementation, I will say the communication between the mobile and microcontroller is also possible through the GSM modem and the GSM technology. So, suppose you are in the center of the city, suppose in the center of the city there is a shopping mall. In that shopping mall, on the top of the floor, there is a display board that's showing the big button. And from your home, you can change the message. You can change their, suppose, come soon. Your system will ask you for the password. If you know the correct password, you can change this. Now, I finally want to conclude with the precious word of the embedded expert Mr. Gear Anderson, the professor of the Harvard University. He wrote in 2008 today's engineer article that the day is not so far when almost all automobiles would interact with the computers on dashboards, from ordering a pizza to booking tickets. At the nearest theater, things will be as easy as giving orders to your son and replacing of embedded system. Thank you so much. Crystal oscillator is such type of electronics device that stables or fixes the currents. Sometimes when LED is glowing, LED is fluctuate, sometimes it is on and it is off. But in this proper position, in the proper timing, the timer is set to we have to know about the timer, the microcontroller, then the fluctuating is not done. When you use this such type of crystal oscillator for stabilizing the voltage and current, you have to use this. Okay.
You are using the REGT2.S header file. What?
Oh.
Yeah. Yes. What is the function this is called?
Include REGT2.H means when you are writing C program in the P compiler, it will take automatically 8052 microcontroller instruction set. When you are writing something in C program, it will convert it to instruction set of 8052. Yes, so you have to use the REGT2.H. Clear?
It means the TIL compiler is optimized with the C and C++ compiler.
In the TIL compiler, you can use C, C++, and the assembly language program.
Okay.
In the assembly language program, you can use the 8051 instruction set and the 8052 instruction set. Okay. When you are writing some program in C, it will be converted in the assembly language for corresponding to 8052. So here is set up.
Okay. What is the open range bidirectional I/O port?
Open range bidirectional I/O port means in the microcontroller, each port 0 to port 07 means there is an I/O input and I/O both can process through a particular line. So it's called open range microcontroller. Open range port with and output is coming in the 0.0 to 0.7. ALU means address match error. It's actually demultiplexes the 80 to 87. Address and data bus are multiplexed here. When A is 1, that means it receives the address. When A is 0, that means it's passes the data. So it's called by open range bidirectional.